Yeah, I can start. Well, my background was originally in physics, and I did a PhD in physics in 2016. But I got kind of burned out with that, so I ended up switching into AI and machine learning, like a lot of other people. And long story short, I ended up getting into research at NIH, where I was working on AI for medical imaging and preventative healthcare applications, risk prediction, things like that. But I actually have a very wide range of interests. So um, and recently I've been writing or trying to write more about what like meta science and new ways of doing science that would be allow for more risk taking and more cross-disciplinary research and kind of get out of this rut, because I feel like science is stagnating. We're producing a lot of incremental, boring research, and uh, there's a sense of progress in science is sort of slowing down, right? So anyway, so when I
Documented.
got, huh?
It's been documented. It's sort of, yeah.
Yeah, like if you look at
Not
when
an
people
opinion.
can the most cited papers in fields, and if you look at the greatest breakthroughs and things, the number is actually decreasing over time, um, which is surprising given that we have exponentially growing amounts of resources going into science. Why are we getting diminishing returns? Is it just that all the low-hanging fruits are getting picked, or are there structural issues um, in how science is run that are contributing? And I tend to think it's a mixture of both. So I think that there is a low, in a lot of fields like physics, for instance, a lot of the low-hanging fruit has been picked, but there's also the way that the culture of science, I feel like, is declining, and the way we're funding things, or the incentive structures are not geared towards um, doing very risky or long-term projects, which is where you would get the big breakthroughs. So anyway, so yeah, so I am a kind of an aspiring meta science writer and researcher, I would say. And also, and I work at the NIH. I actually left the NIH for a few years, but then I went back. And so, in my day job, I'm um, doing some research on AI for uh, healthcare applications. Um, but really, my passion now is more in this area of meta science and writing on my blog. And so I was um, very excited to get involved with Ekkolápto. Um, and I think Addie and I really hit it off. And so he was, I have the honor of being like a scientific advisor now at Ekkolápto. And I hope to be more involved going forward.
Okay, hey, so I'm Ilan Barinholtz. I am physically in Maryland, but spiritually I'm in the Machine Perception and Cognitive Robotics Lab in Florida, in Boca. So I'm a co-director of that. Some of these folks are active students there, and some of them are have been affiliated with that institution, which is in some ways the progenitor sort of for the sort of this meeting and this sort of current incarnation. So that's by way of broad introduction. I'm going to jump right into what I'm working on right now, and so I'm actually pursuing. So I think we've solved the brain. I think it's just an autoregressive next Dugan generator with residual activation, which is basically the entire system. And so, in a nutshell, I'm pursuing that sort of that theoretical framework. And it's based over the course of these meetings. Hopefully, I'll have a chance to interject what I mean by that and how I'm personally pursuing it, and maybe try to convince other people to hopefully join in at least at the conversational level, but also This is what this is what I want to work on as a group. It's within the lab. One of the things I'd like to work on, and I know there's one of the purposes of this meeting. I think is for all of us to hopefully to converge a little bit, not just say, "Hey, I want to talk about this today," and people can offer advice, and maybe they'll join in, sort of auxiliary to it, and then there'll just be these disparate projects. That's one way we could do it, and we could all just talk about what we're interested in individually, or hopefully, I think the goal would be to be like, maybe through the marketplace of ideas, we call it a competitive marketplace. Maybe some of us, their job is to convince everybody else to be interested in what they're doing. Call it whatever you want, but I think it'd be great if we could think about how we could sort of converge, at least maybe not on a very specific individual research project, but sort of a theme that we're all pursuing together, rather than things that really just sound kind of cool and interesting, maybe a little computational, but there isn't exactly clear why we're all meeting. So that's what I'm hoping is that from this kind of meeting.
Yeah, I want to just say I support that, and I have my own. I do see there is with Ekkolápto. While it is extremely multidisciplinary, we have all these different researchers that are sort of involved. I do see actually kind of an overarching theme emerging, but I'd love to discuss that. Let's do the rest of the intros first.
Hi, I'm a PhD physics student at FAU and also a member of the MPCR lab in Ekkolápto. And I am also an affiliated researcher with the Wolfram Institute. So I actually disagree with something that Dan Elton said earlier, that in physics, a lot of the low-hanging fruit have already been picked, or that there weren't many low-hanging fruit left. Because I researched general relativity, specifically vacuum GR, and there is a lot of low-hanging fruit which I just keep tripping over. So also regarding complexity sciences, I think that there's a lot there that can be discovered, that there's a lot of low-hanging fruit, and it just people need to just go searching for it, essentially.
Yeah, I actually wanted to comment on that real quick. I'm sure in every generation of scientific innovation, they could have thought easily, wow, we've covered a lot of here. We've sort of gotten the low-hanging fruit, because you don't know what you don't know, right? And so since they couldn't conceive of quantum, for example, they simply couldn't have had the idea that maybe we haven't already hit the limit. And I think we should absolutely, of course, assume that we're perpetually going to be in that. Every generation, in some sense, will have picked the low-hanging fruit that they were able to see, but which is, in this case, we didn't have AI yet, for example, right? And that's obviously a game changer. So I think our working assumption should be that so in answer to the question of what's the problem with science, and there does seem to be a decline in innovation, I think it's a structural problem. There's plenty to do. There's plenty to, right? The innovations are not coming because the system is not innovative.
Yeah, I largely agree. I just I think there are some. I think that there's something to the low-hanging fruit argument. It's actually popular among economists. There was this paper, it's called "Are Good Ideas Getting Harder to Find?" By economists, and I think there's something to it. But yeah, I generally agree with what you're saying. It's not the main thing. It's not the main reason that science is giving diminishing returns for investment. Yeah. Anyway, Michael, it'd be great to it'd be good. I actually think Michael and I, maybe we should chat sometime. So yeah.
But in any case, so that's one of the purposes of this group. Let's say that is to somehow drive scientific innovation, in ways that maybe aren't happening well in the traditional structure.
Yeah, I think that's part of Ekkolápto is to experiment with different ways of doing science that maybe more multidisciplinary, more conducive to ideas that would be outside of the normal sort of purview of a lot of, mainstream funding. Yeah.
Amen.
Yeah, I was really excited to see you to hear so much talk about meta science from everyone. Because I'm also interested in meta science, but maybe from a different perspective, less of like sort of a structural organizational perspective and more from a workflow perspective. I think artificial intelligence and LLMs have the potential to be tremendously useful for scientists, and they've actually demonstrated capabilities that have beat scientists in certain areas, like novel and useful hypothesis generation or generating high quality bioinformatics code, things like that. And so I'm currently building systems to sort of realize those capabilities and potential. So I've got one system I'm working on for computational neuroscientists where they can sort of plug in a theory and the AI on its own generates hypothesis, generates experiments, runs the experiments on a computational data set and reports back with the results, and sort of leaves the neuroscientist with only sort of the very hard thinking of coming up with the elegant theory from data, and allows them to do sort of the grunt work of writing bioinformatics code and getting the results with the AI. And then I've got another system I'm working on that is focused on being something like an upgrade to RAG, or retrieval augmented generation. When these RAG products were coming out, I was really excited as a scientist and knowledge worker. I was like, oh, this is going to be great. I can pour all of my documents in and ask questions in natural language. And quite frankly, they suck. And at least for the sort of deep reasoning that you need for scientific work. And so I'm working on building a sort of new type of RAG system that's better for that type of deep reasoning, and it's more focused in on that than, say, retrieving customer support tickets or something. As far as my qualifications, I am a PhD student, very soon to be candidate. Alon Barinholtz is my advisor. And yeah, I've got several ties to this group outside of Ekkolápto, even.
Can I just point something out, which is that at the sort of initiation of your dissertation research, actually we had an initial meeting, if you recall, and the committee met, and we kind of, so you were going to do this hypothesis, first of all, hypothesis generation, and then hypothesis testing. And to some extent, the consensus ended up being like hypothesis generation. That's a little too, that's a bit much. And now you can't even do it. It's not novel anymore. It's like we went from being like, that's way too novel, we're never going to get there, to like, oh, that's already done. Now, Daniel certainly got, you have a piece of this that you haven't fully disclosed in terms of, the full execution and all that, which I have not seen anything like that yet. But it's just crazy, just how quickly things are changing. That's what, the idea that we're in some sort of basin of scientific innovation is just can't be. I mean, it's just getting started. But yeah.
It's super interesting because I'm actually working on something similar. I'm just getting into something similar, and which is a little more along the lines of AI for scientific reproducibility. And so essentially, if you have if someone publishes a paper and they publish data, I think there should be more requirements to just publish your data. And then what I'm looking at is using AI to replicate the result, to analyze the data, to replicate the results in the paper. And it's gotten to the level now where it can actually do that. So, I mean, I'm just getting, I am literally like just starting to use deep research, and it's absolutely mind-blowing what can be done. So I've had to rethink a lot of my thinking. Just
check your sources, though, by the way. Just be careful. It does hallucinate. I've caught it, at least as part of I tried to find it. was, there were certain.
Yeah, we just had an issue with this week.
Yeah, I know. Yeah. So I think we got to be careful, but I think that, I think that what I'm not necessarily saying it's going to replace scientists. I'm saying it can be useful to check scientists' work,
Fix like peer
basically,
review.
It's spectacular.
which is
as
a
an
little bit
assistant.
lower, bar, because, it's basically looking for errors rather than, and if it makes a mistake, it's, I like false positives are not as big of an issue. Like if it makes a mistake, like we want to find errors in work that's been published, or even signs of fraud, for instance. And
Oh, wow.
anyway, so that's what I'm looking at personally. But it's
That's so
pretty
interesting.
interesting.
We could go retrospectively and churn through the literature, and maybe it'll start to find. Oh my!
Create more replication.
Careful.
Right? Yeah, so rigorously checking existing work is very difficult, especially because you don't have, usually you don't have access to the data. But
Right.
yeah.
That goes back to the first point you made, which is everybody should just be sharing their data rather than their report of what they claim they found using whatever brew of statistical testing they may have performed or not performed.
I will say real quick, I think augmenting scientists as opposed to replacing scientists is absolutely the right way to think about it. That's where the low-hanging fruit is, quite frankly. It's like, if you're thinking about like the 80-20 principle, it takes like 20% of the work to develop a system that can automate 80% of a scientist's workflow, and then you just leave the other 20%. And like for my system in the early test, I was able to crunch 8 or 9 hours of work into like 25 minutes, and I'm okay with not going after those last 25 minutes. That's fine. I'm going to keep trucking away on what I've got.
Those are the good 25 minutes, right? That's like, yeah.
Yeah, those are the fun ones. Those are the thinking really hard about a theory and working on the math.
It's similarly. I mean, it's just such an accelerant to think about the stuff you want to do. Searching through papers there's just not a good use of your time, right? There's just, you can't. If you can skip that, then you can't make an actual constructive argument as to why you'd want to not hand that over to a computer. Find me the relevant computers. The only one is maybe it's not going to do a good job. But if it does, there's no reason. Right now, reading papers, actually reading them, and as opposed to just sending them through the system and asking to summarize, asking specific questions, there I could absolutely make a good argument that in many cases that's not going to cut muster. But for some for some grunt work, like even high level grunt work, because it takes a very good graduate student to do a really solid. Just find the right papers. If you're talking about a technical and potentially multidisciplinary kind of topic, go ahead. Good luck, right? So,
could we, real quick, Alon, do we want to get a quick intro from Brian and Reese if they're able to, just before we?
Yes, please.
My name is Brian, and I'm a software engineer at Soapbox, and also an affiliate researcher at Wolfram. My main interest is computational neuroscience, and I've done some research in the, not quite research, but mostly like an interest I've developed. And at Wolfram, I do mostly programming and modernizing the NKS book. And also I'm looking into the possibility of using Turing machines and cellular automata to understand attention and memory in the human brain.
What's the NKS system? Sorry, I'm not familiar with that.
Well, it's not. It's the new kind of science book to modernize the color, the figures, all that stuff.
Wolframites call it NKS because okay.
Yeah.
Hey, my name is Reese Hayward. I'm an undergraduate health science major at FAU. My interests span from philosophy, exercise, nutrition, neuroscience, but I'm right now getting into iOS development, so learning more about Swift, Swift UI, and UIKit.
Tell them what we're really interested in and what we talk about.
Well, I would say a good amount from our last salon. We were talking a lot about micro stressors, and which is really interesting to me, honestly. I was looking more into it, and I was actually watching a lot of Michael Levin last night about collective consciousness, and yeah. So I was trying to I was trying to go kind of down a rabbit hole last night about maybe the connection between hormesis, the gut-brain axis, collective consciousness. So yeah, it's kind of a wide variety of biological topics, but yeah, just the importance of exercise and nutrition, and seeing the real effects on the body.
And Reese, the interesting thing with that, right, is that I think we sort of make a distinction between the mind and the body, but I think as we can see that even the health of your body can very much impact the functionality of your mind, and in a lot of ways, I think I'm very inspired by what like peak performance athletes do, because it's not just a physical game, it's also a mental game. There's a lot of like high level technical strategy and all that type of stuff, and also you've got to have decent amount of an attentional capability and memory capability and all these things. And actually I can sort of mention on the topic of like coordination and rhythm, is if you hear from like a lot of team sports players, they'll often say they kind of feel a rhythm of the field, right? They can actually feel sort of the rhythm of where the team and everything is going, because you're acting as a team, but everyone's doing something slightly different. And so I think there's a lot from sports science, exercise science, that sort of this field of complex systems and philosophy can probably take a lot from.
I'm working with Ekkolápto and the MCR lab, and Alon, and Lindsay, and a bunch, almost everyone else here. The root of my interest is always been music. I always tie everything to what music is fundamentally, but my main research focus is systems, language, knowledge representation, theoretical computation stuff, and anything else that can be involved in that. Dynamical systems modeling, econometric stuff every once in a while, game theory.
Misha is just interested, like just in general, like just interested in anything basically. He'll always find something to sink his teeth into.
Interested and interesting.
That too,
But deep
yes.
down music.
Sophie, you want to
somehow
give a
music-
quick intro?
Okay. My name is Sophie Frandiaz. I was a neuroscience and behavior major at FAU, and I'm really interested in biomedical engineering and neurodegenerative disorders, specifically Alzheimer's I'm really interested in, and microfluidics. So for the hackathon, my concept was using machine learning and multi-omics data sets to find novel biomarkers, and then validating those biomarkers on brain-on-a-chip organoids to kind of model the disease through microfluidics and validate those biomarkers through like different types of like microelectrode arrays, TEER, and then doing machine learning to better the algorithm to find better biomarkers. Yeah, I like studying very complex chronic and progressive disorders.
Cool.
Dan Elton, you think there's any overlap between? I'm treating you as kind of the special guest today. Any things that have sort of caught your eye?
Yeah. Well, let me think here. I came into this with no prep, just literally a minute ago. I have no. So let me collect my thoughts here. So So with Ekkolápto, I mean the thread that I think unifies a lot of it is this idea of enhancing cognition,
Correct.
right? Whether so by, and this, it kind of ties into a lot of things because like we can use AI to enhance our abilities. We can use various types of training to enhance our cognition, whether it be the training our olfaction, training our power of concentration through meditation, training our awareness through meditation, training our vision, visual acuity, visual perception. So that's kind of like, I see a lot of that's kind of like a big theme I see. But we've also got, you've also got a number of researchers who you've identified that have exceptional abilities that are maybe underappreciated, right?
Correct. Yeah.
Would that be fair to say?
Yeah.
Yeah.
That's a fair statement. And at the end of the day, I think I told Alon this well. Like I said, listen, my actual real big goal is to understand is sort of the unknown unknowns, right? Why are we here? What are we doing? What are we supposed to be doing? I'm just very interested. Part of my interest in the cognitive science and neuroscience and all that, and enhancing intelligence and cognitive ability and all that, is I do feel like what are some things that we're just not seeing, right? What are some things that that are just not even in our lens of viewing things at all, right? Something that we just haven't even possibly considered. And if you look at a lot of these sort of interesting innovations in technology and science and whatever, is some of those biggest ones just come from very different perspectives. And so I actually very much celebrate people that are not neurotypical, because usually their lens of viewing the world is quite different, and that may lend to some very interesting perspective on solving an issue. I've spoken a bit about the lens thing, like I spoke about it on the podcast on the Meaning Code with Karen, if any of you have seen that. I'm very interested in sort of the ways we can train ourselves to literally experience sort of the quality of the world differently, right? That was the idea behind the olfactory language, all that type of stuff. And I do think there's a lot to be done for cognitive enhancement that doesn't need to be expensive or hard to make or anything. I think there's a lot of things that, like if you think about this, right, like these very advanced meditators for all of the, at least the history that we understand, they were basically sort of the original cognitive scientists and biohackers in a lot of ways. And I think there's just a lot that we can learn from just experimentation with the way we're perceiving the world. And so I want to kind of take into consideration, right? And this is also something Misha could talk about with the way music affects cognition. But maybe there's a different way of experiencing like mathematics, right? What does mathematics look like in a different language? Right. So I used to experiment with the olfactory language and math, and where you can calculate numbers and store that information doing it like that. But what are some other ways of experiencing mathematics? Because this is also something that these people with savant syndrome seem to claim, and it seems that they're able to experience math differently, even though technically they're getting the same end result, but the path is entirely different.
You know who I think is, how many people here are familiar with John Vervaeke?
Me.
Yeah, because I think that I feel like John Vervaeke is sort of an intellectual, what's the word? He was sort of a influence on Ekkolápto, right? Because John Vervaeke's whole thinking is that So traditionally, people think meditation is this spiritual practice to get in line with God or the oneness of the universe or whatever. But John Vervaeke's thinking is actually the reason that meditation and other types, the reason that people seek out these unusual states of consciousness is actually it actually has an adaptive purpose of enhancing cognition in certain ways, to get insight into the nature of reality, to get insight into how to solve problems for your tribe. It has practical utility. In other words, it's not just this religious thing that people, it's not like there's this idea that people go into caves to meditate to just, gain, for this kind of like religious thing, but it's actually got his whole in his view, it serves practical utility for survival of the species. If we have some people that are doing these practices which ultimately enhance their cognition or give them special abilities to do for instance of intuition and things like that. Anyway, I'm still listening to his whole lecture series, but yeah, I feel like he's a kind of intellectual influence on Ekkolápto. Would you say that's right?
Yeah, no, I was saying, I think like a lot of the people in terms of scientists and researchers or whoever today that I've heard a lot of ways, right? I mean, definitely Michael Levin. I kind of have a bingo card thing for the amount of times I'll bring him up, but then also definitely Wolfram and everything that Stephen has done. I think there's even some people from the Wolframans that are here on him. I'll say Becky, Kurt isn't technically a researcher in the traditional sense, but everything he's done with theories of everything has been a giant curator for people like, really all of us, right? And definitely Friston.
I like it this way. I mean, certainly you need to be able to have this larger audience, group of people who can't always be together. So this is very helpful.
Yeah, I feel like we're reaching more people this way, because I know a lot of people over the last couple of months are like, yo, like you got to do something online for this, because like I can't join or whatever in person. And I was kind of putting it off, and then I just decided, all right, let's actually, something we could lead with is sort of bridging also from the last conversation about ways of sort of biological coordination, right? And you could say that physics is a way of coordinating different forms of biology. You could say, when you're exercising and you're stressing your muscles, in a sense, that's also coordinating certain muscles to act in some specific pattern in response to that stressor, right? And I actually think, one of the things I want to get into with Ed Large, right, is like, what are sort of the earliest forms of biological coordination that we can think of and know of? And if we can identify what those are, how useful are they actually there for changing our behavior or physiology? So biological coordination. So this could be things like motion, circadian rhythms, ultradian rhythms, stuff like that. And then we'll bridge it into more physics things later on.
You think there's a rigorous definition of coordination? We define what constitutes a system, and then what constitutes coordination between them. I don't know much about the field, frankly.
I mean, amoebas move a lot. Paramecium,
I mean, coordination dynamics.
The vibrations between atoms, does that constitute? Is there coordination happening if there's nearby, subatomic particles that are somehow influencing one another? Is there? I guess that I don't know if we want to delve too deeply into that, or is there just a sort of an intuitive feel of what it means?
If we're going to be talking about coordination, we should invite Kelso to one of these calls. He's like the guy in coordination dynamics as a subfield of complex systems.
Oh, sorry, Addie, could you elaborate a bit more on that?
I work at the Wolfram Institute as a research coordinator.
Okay, cool.
My background is in mathematics and geometry.
Nice work. Okay, I'm
I think
Samaya.
I do.
I'm a medical
Yeah.
student actually in Boston at
Mhm.
Boston University School of Medicine. I've worked in a couple labs, and that's kind of how I've gotten introduced to Ekkolápto through like friends and being at a couple of their conferences. And but I've worked in cognitive science of religion. I've worked in neurodegeneration. I've worked a lot with clinical like patient care. So I definitely am very pragmatic. You know, you're talking about like what is a coordinating system. To me, it's about these mechanisms that we can actually see interlocking together. I am really interested in like interdisciplinary interaction of that. I'm really interested in sleep medicine also. So if we're trying to like relate this back to the main, I think what Addie was trying to talk about, like circadian is really interesting. And I think there's going to be, I'm hoping there's going to be a lot of development in circadian like data analysis. Hopefully, like sleep medicine as a subspecialty, hopefully we'll have some change happening. I don't know who else is on this call, so I don't know if medicine is what we're, if anyone else is interested in that, but yeah.
I was saying earlier, like the kind of like a big theme I see for just Ekkolápto is like cognitive enhancement, and
One day, we just say it's applied. It's applied. I mean, that's one way to put it. Is the idea is to do something with the information, not to just have insight, but rather use it for, you know, in this case, enhancing cognition, maybe, or maybe not just cognition. I think cognition is very. You tell me, Addie, if I think that's maybe too limiting, right?
Yeah, I'm really, you know, we have a range of different topics we want to talk about. I think everyone's kind of introduced themselves, right? If they did while I was off the call. And I really want to understand this idea of a, you know, a collective intelligence, a collection of systems, right? So a collective, right? And you know, in order for it to function and to be categorized as a collective, it sort of has to act in coordination, right? And you can say that as if, you know, it's a flock of birds, it's people on a sports team, it's cells, it's chemicals, it's all these different things. How are things coordinated? And I think something interesting to dive into with that is the way things kind of certain, we're coordinated by certain rhythms, right? And rhythm is really just sort of maybe a fancy way of describing the way we entrain to something, right? A certain pattern of things, right? Sort of, you know, if you think about what happens with music, right? Like there's nothing about the sound itself that should make you move your head up and down, which a lot of people will do to feel the rhythm per se, right? But this seems to be a sort of a pattern in biology in a response to these sort of pulsing sounds. And I'm going to wonder, you know, cognitively, I could say, you know, what's specifically happening neurologically in the brain, but I'm more interested in the bigger abstract idea of a cognitive system, whether it's a human, bird, AI, whatever, as to why we're able to entrain to things, right? How do multiple units entrain to some specific, you know, set of coordinations that keeps it acting as a collective, right? And then we can tie that into things in other fields. So I just want to get on this thing of biological coordination, right?
yeah. Okay.
Can you tell me why? So are these two things related in the sense that you feel, you know, going back to the earlier point about, you know, Dan's point, is that a theme here is things we can apply in a sense that, you know, let's say enhanced cognition, maybe more broadly than that. Do you see coordination dynamics as being a particularly fruitful potential? Why are you interested in it? Is it because you somehow sense and see almost like obvious low-hanging fruit, to use the term from earlier, that might be a fruitful direction specifically for this kind of enhancement, or whatever it is that whatever term we're using?
Yeah, I do. I think, you know, when I immediately sort of what I think about when I think about coordination, right, is what other rhythms are there that could be, you know, useful for surviving and getting things done that we're not usually able to pick up on. Because if you actually sit, you know, outside and you hear things, there is a sort of rhythm and pattern to things. And the question is how helpful is it to tune into that in the first place, right? And remember, not a rhythm doesn't just have to be auditory. It can be visual, right? So surgeons, when they're, you know, operating on a heart or something, and they're looking at the thing visually, even if they're not hearing anything, you know, a really good surgeon will sort of be able to tell, you know, looking at the heart and moving, and be able to tell the visual rhythm of that, right? And you know, what does an olfactory rhythm, you know, experience feel like, right?
Yeah. I think Elon, what he's talking about is on the more individual level. And what I would bring in, what I think is the concept that might be relevant here is this idea of the flow state, where you are coupled to the environment in a way that is some sense optimal, right? So you're not overwhelmed with where you can't process all the information you're coming in, and it's your system is can't keep up, but you're also not you're not bored, or your mind's not wandering around to other things. You're really locked in, right? So that's what comes to mind to me, like this idea of the flow state. Yeah, like a surgeon might get into a flow state where they are especially attuned to like the heart, the pulsing of the heart, or these other micro perceptions that normally you wouldn't be very aware of. Is that kind of what you're talking about?
Right. Yeah, in a sense, and actually, I think I can maybe expand on this a little bit more, because yeah, you're right in a sense that a lot of my stuff is trying to figure out, how can we improve our physiology, right? Our bodies and our minds through, ideally the most sort of low cost, least invasive things possible, right? And something that I think about, right, is say athletes, right? Do you think, would you, and this is just an opinion, and I'm asking, do you think athletes, like very, very good athletes or gymnasts, have some level of a good sense of physics around them to a degree? Would you agree with that, or maybe not?
I mean, they certainly have a good sense of their body, the physics of their body.
No, but like they'll be able to sort of, they'll get a feel for how to throw the ball or how to move this way or do that. And yeah, I'm not saying it's gonna do anything on an astronomical scale per se, but it is interesting that there's a level of you can sort of feel in tune with that, and then you don't even really have to think twice about it, and it's sort of second nature to you, right? And I wonder what, if you look at that as an almost sort of like a sensory synesthesia type of thing, what does that look like for having better understanding of physics? Right? Is it possible that, in the field of physics or math or whatever, is that these ways of experiencing the world, they had some type of synesthesia or whatever, and they were just experiencing it in a, in a more sort of visceral way, that we normally wouldn't use language to explain, and that gave them a certain insight because of the perspective that thing took, right? So, I think about the, savants and all that, where, if you get knocked in the head a certain way, or some people are born with it, usually on the spectrum, right? They have these pretty insane memory capabilities. Like, good luck taking any of us and flying us over London or New York or wherever, and being able to draw the whole thing in one go without looking at any reference, right? So I'm very curious about, like, if we know of any people with very interesting cognitive physical
I
capabilities,
think an
right? What are the
interesting. So some of the stuff about, I think, drawing a city on one glance, I think some of that has been overblown, honestly. But obviously there are people with photographic memory and stuff. But an interesting constraint for physics is working memory. And
Elon, this is your game.
I'm just gonna hold my tongue.
Shockley, there was a William Shockley. I don't know if any of you are familiar, but William Shockley, the physicist, he had this idea that exceptional physicists, people with higher IQ, that the limiting factor for determining physics ability was working memory. How many things can you hold in your mind in your short-term memory at the same time? Because that because that determines the amount of connections you can draw. Like the number of connections between n things grows n squared. So if somebody can hold 6 things in their mind instead of 5 things, they're able to see, 36 potential connections instead of 25, which is, it's growing. So
can we define working memory here? Because that's something that's got a lot of different conflicting definitions in the literature.
Maybe Elon knows more about it.
It's operationally defined. It's operation. So you just hit a little bit of a nerve. Not
deliberately.
The whole idea of working. No, I don't. Well, if you did, well done. So operationally, it's defined as the functional capability to be able to explicitly recall sequential information about things like digit span, almost exclusively about things like digit span. And that's the sort of working definition, and it's a measurable property of people. It's a stable one. In general, you find, if you we get Dan in a room and had him memorize 6, 7, 8, whatever number of tokens in a row of letters or numbers in a row, we'd find maybe he can accurately remember some of their specific amount, and then we take him 5 years later, and you probably have a similar span with some noise, and then Misha would have some other span, and Daniel would have a different span, and they tend to be stable. It also correlates with other stuff, but that's sort of the operational definition. It's this capability to explicitly recall sequences. My personal opinion is that's not its function at all. That is how we've discovered that there's some properties of something that whose performance we can measure. It is a measure of some performance, but my personal opinion is that it's not in design, its purpose is not explicit retrieval of sequences. That's something I think we almost never ever have to do. And more importantly, I think there's very likely what's really going on. Sorry for sharing this so much, but we're not really discovering memory. There's no memory. There's no such thing as memory. There's no memory buffer where we hold stuff in fact, what we have is just residual.
There is for audio.
Sorry?
There is for audio.
No, there isn't. So that's what I'm saying. And my claim, and it'll take a long time for me to fully unpackage it and back it up, but we don't preserve activation. Rather, what we have is residual activation, which then feeds into the current generation. So in this case, what we see when somebody can retrieve those numbers, but that's not really the purpose of why that capability is there for other reasons. It's because you need residual activation to guide whatever you're going to do next, whatever you're going to say next. And so that's just in a nutshell. I don't think that's the function of it, but at the same time, you do find, of course, there are these reliable relationships between the measurable property of what's a digit span, for example, and things like general intelligence and IQ and things like that. And so that's not to say that its function is to do that, but rather what you're measuring. So the decay function of sort of residual activation is going to predict your digit span. So in other words, if this sort of residual activation, which feeds forward to your next generator, sort of the next activity, the output of the system, if you have a more robust activation, you're going to be able to do both explicit retrieval, which is what you measure, but also lots of other stuff, right? So in other words, it's kind of a nutshell, an easy way to think about it is the reason why it's correlated is because it's not because you can hold a bunch of stuff in your head. That's the tail wagging the dog. That's because that's what we measure. But what we're measuring is probably, in my view, and I don't think it's hard to see that this might be the case. What we're really measuring is sort of this decay function of sort of the availability of information in the recent past and the ability to use it. In that case, we happen to have this particular way of measuring, of using it, which is to regurgitate. But as I pointed out, and I'd like people to fight me on this, that's something we have to do all the time. And I said, when do you have to do all the time? Explicit retrieval, how often do you have to say, what were the exact last few words that somebody said? How often do you have to repeat that? Or think about the exact words you said? And he said, we have to go
quite frequently in law school.
In physics, when you write on the board, I'm like, that's not ecologically that's not an ecologically supported activity. Like, we didn't evolve the ability to do physics on a whiteboard. I don't think that that's something we do is explicit retrieval.
I do that quite frequently in law.
In physics, you do. So I think we use whiteboards to augment our deficiency in being able to in our short-term memory, right?
Right. Well, so
Like in physics, we have to
I'm just saying this
keep track
behavior
of.
of going and what were the last, what's a typical short-term memory task? AGLFRMNT. Say them back, right? When do we have-
AGLFRMNT.
I don't even remember. So well done. But I started talking in between. So there's interference, which is also a construct based. So I guess what I'm saying is that you don't have to do that kind of thing almost ever. I don't think that's what it's for.
Again,
It's to build things in
in law,
sequence.
you have to do that all the time.
But in physics, so in physics or engineering,
When
though,
did
like
you-
you have, say you're trying to design a nuclear reactor, right? And you have to optimize the, say, diameter of it or something. You have to consider multiple variables at once and how they all interact.
Sure.
Right.
I think
So
we do. But
now,
the specific task that we're doing.
somebody with who can actually keep all those variables in mind in their own head, I think is going to be a better scientist than somebody who has to put them in, on a whiteboard and kind of piece it together that way. And that's what William Shockley was saying, because what he observed was like that, scientific productivity is has a long tail of a few people that are exceptional. So
I think what Alon might be saying, and correct me if I'm putting words in your mouth, is that when he's talking about what it's for, he's not talking about is it useful for things in the modern age. He's saying, if I'm a caveman going around and trying to like kill dinner and bring it back.
No, I'm saying for the modern age. I disagree. I'm not saying
for the modern age. Okay.
Again, for lawyers, lawyers do this all the time.
Sequences in a very specific serial order, which is the only thing they measure. When you talk about holding concepts in your head and things like that, they're not measuring that at all. Now,
what about
it's correlated, and
what about,
sort of think, that's probably what it is. But I'm saying
what
it's
about?
not what it is.
Aren't there other tests like regarding? So like a test somebody told me one time was, picture the Earth going around. Picture the Earth going around the sun. Okay, now picture the moon going around the Earth and the Earth going around the sun, and see how many planets you can visualize, moving, orbiting each other. I mean, I think most people can do.
I'm going to interject here, by the way, and say that hyperphantasia sort of throws a wrench in this to a degree.
So, like, you can model in your head. People who are so let's put aside people who are aphantasic.
That's very hard to measure. Very hard to measure.
Let's put aside people who literally are aphantasic. But for those of us who can see things in our mind's eye, I think most of us can model the moon going around the Earth and the Earth going around the sun. Well, then I think when you put in a fourth object, like a satellite going around the moon, and the moon going around the Earth and the Earth going around the sun, like it's very hard, right? Aren't there tests that cognitive scientists?
I'm not familiar with any because it's very hard to. I mean, the problem with that is
there's like mental rotation tests.
There's no objective measure.
Mental rotation, but that's a little bit. I'm thinking more about
the reason why they love. The reason that's why I say it's the tail wagging the dog. The reason why they came up with the whole concept of short-term memory because it's easy. You can measure it. It's just it's objective, and you have a serial, and it's not asking people to report what's in their head. If you ask me, can I see 3, 4? I don't know, and I can say what I see, but there's really no way to actually pin that down and say, okay, you have a rotational span, of 4 objects or something like that. There isn't really
right.
Anyway,
and there's people who claim that they can visualize 4 dimensions, and there's another one. Which how do you prove that though? But if somebody could,
short-term memory is exciting because it's measurable, it's discrete, it's objective and numerical, and it's predictive of other stuff, which is one of the reasons people think it's actually interesting. Is like, oh, okay, we really found something here. But again, it's just the thing you happen to measure, and maybe it's correlated.
That's another one. I did a lot of work on visualizing 4-dimensional hypershapes, and even though I can like make them on the computer and like have some semblance of where I put the material for the hypershapes, I can't yet just close my eyes and try to like be there.
What do we mean by
with,
visualize those? Do we mean like visualize 4D rotations?
Yes, and like taking polytopes, let's say, and taking cross sections of them, three-dimensional cross section, or parameterizing a three-manifold. Daniel, you mentioned William Thurston, I believe.
Shockley, yeah, William Shockley.
So there
No,
are
no,
people
I
who
brought
say,
up William,
Yeah.
Bill Thurston. I brought up Bill Thurston.
so
Oh,
there are people who say that they could really, or say definitively that they sort of qualitatively can experience sort of the fourth dimensional thinking. And
I mean, I can think about hypershapes and like how they're structured to some extent.
okay, are you seeing
but-
Qualia different?
My Qualia is still like a two-dimensional retina projection of slices, but like there's sort of a representation of, okay, well, at the bottom I have like a sphere, and in the middle I have like a torus, and at the top I have another sphere again, and this shape is sort of spanning those nodes and the equator.
Yeah, I can think of.
Go ahead, Michael. Sorry.
I can think about like four-dimensional structures as well, but if I'm actually generating images, they're always limited to being 2D. But like I can represent like a 3D object with like a 2D image from a certain perspective. And you could try doing that with like a 4D object, which is just like doing an additional projection, I suppose. But that's really the most I can do.
I just sent a paper as far as the 4D space thing. Qualia is a whole different thing. Once you bring Qualia in, you automatically make it, I think, non-reproducible and unscientific.
Well, but with portability, at least even if we just accept portability, I'd still be interested if somebody says, I have this Qualia. It's different. What can I tell you? You have to believe me on it, but I'd still be curious to know. And then you want to see if maybe they have some other ability you can measure from, who knows. But go on, sorry.
What I just sent though is a paper that shows that humans can learn to effectively navigate four-dimensional mazes. And so it has to be a learned skill. They don't start out, I don't think anybody in the study started out able to effectively navigate 4D mazes, but if you give them practice and let them sort of explore the four-dimensional space in a computer simulation, humans can learn to effectively navigate it.
The cool
navigate
idea.
and visualize 4D rotations are two completely different things.
Sorry.
I was gonna say, but also the cool idea would be, what can you learn that would transfer off to let you, be able to navigate a 4D maze? Like, what could you learn in a lower dimension that lets you transfer over to that, right? And what is like the lowest amount that you can go?
I would just like to add that there's this game called 4D Golf made by Code Parade, and I haven't played it, but I've heard
It's a
people
blast.
who I've heard people who like do play it like can quickly like learn how to like actually work around in like 4 dimensions. I'm not
The
sure
5D is kind of interesting, although kind of hard to get your head around.
Interesting.
Yeah, I was looking at the way he was coding that up, and the way he was slicing his pentatopes and whatnot. I have a lot to say about all that.
Yeah, actually, Dugan, let's hear more from Dugan. Let's hear more. He's a new guest.
Yeah, welcome. Yeah, I mean, thank you for having me. This is an interesting salon. Yeah, so I sent a link for one of my videos of hypertorus being sliced at the equator as it tumbles. Does some four-dimensional rotations. So that one's a lot of fun. And let me share something else that I did. So this is a hypertorus. This is an extruded torus. That is, you make a torus by taking a circle and pulling that around a larger circle, and that extrudes a toroidal, the surface of the torus that way. And then 4 dimensions, take a whole torus and you pull that around a large circle, and that'll extrude out the material. So what this gray thing is in the background is sort of the outline of the outer and inner parts of the thing. That is to say, you have an outline going around the exterior, and then on the inside you have the void that is the extrusion of these holes, essentially, is where the material is not. So the material is confined to the sides of this this shape here. This first movement is translating it up and down in the W axis, the fourth dimension. And the second movement is applying a rotation. So you're seeing different equatorial slices in different orientations. So the idea is that that there's in a given hypershape, you have like a story of the slices of what happens. So you have like these, here it's like you have this is a two torus at the bottom, two tori at the middle, and then a torus at the top. Now I add twists. So what's happening here is if you take like an oval, a thin circle, let's say, and you pull that around a circular path, you get something like a squish torus. And if you take that and you kind of propeller that along as you go, you'll have like a twisted up torus. In the 4 dimensions, you have the same sort of freedom, although you can take the thing that you're extruding around a circular path, but you can tumble it on any number of 3 axes. So this is adding a twist in one of those axes. And then in that static hypershape, panning up and down and applying twists. So, and what's fun about this one is the equatorial slice in this orientation is a trefoil knot.
So can I ask you a question? You spend a lot of time with this?
Mm-hmm.
So do you get sort of an intuition the same way? Okay, if I have an object, here's my object, and I say I want to see what's on the other side over here. I kind of know that I need to take a certain perspective in 3D space to see that which is obscured right now, sort of by the shape itself, right? Self-occlusion. Would you similarly be able to kind of, do you have an intuition as to how to go and move around the shape so that you can gain the perspective you want? Are you kind of intuitively moving through 4D space in that sense?
The idea is, no, that's something I want to get an intuition of. And the way I want to do that is sort of be able to like navigate.
Yeah, exactly.
Through these spaces. So set up objects and
oh man, you could do this in VR. It'd be kind of cool. You can use your whole body navigating through
showcode if you do
space.
Yeah,
it's actually a pretty cool idea.
The initial idea.
Do we still have VR sets? We used to have a bunch.
Yeah, I think we still have 3 in the lab.
It'd be a fun project.
Yeah,
I think there's already some code for that.
Get into,
yeah, then you could definitely measure even efficiency if you have to just get to a spot.
The slice problem for polytopes, not just smooth shapes that are parameterized, but polytope objects which are like polygonal.
You'd think the slice for polytopes would be easier.
It's a completely different way to go about it. Actually, what I first figured out how to do was to solve the case for the parameterized manifold. So that hypertorus essentially was kind of like my first aha moment. So that takes, you have to parameterize a 3-dimensional. So like a surface is like a 2-dimensional coordinate patch.
Sure.
Thing. So you parameterize it like with 2 dimensions. These hypershapes take a 3-dimensional coordinate domain and map it into 4 space, and you could take isosurfaces from there. So it turns out to be a tricky manipulation of isosurface functionality, essentially marching cubes algorithm.
Uh-huh.
Dugan, how would you go about visualizing a higher dimensional structure if you also have like complex coordinates? Because like it's easy to visualize like a 1-dimensional like complex plane, but for higher dimensions, it becomes very difficult, I found.
I found the same thing true. So, I mean, essentially complex, you're dealing with 2n coordinates. Real coordinates, that is, it's twice as many. So,
Sure.
but yeah, like, let me try to find.
How did we end up on 4D isotopes?
Well, I mentioned.
I don't know, but I like being here.
I mentioned four.
I actually have.
There you go. I like that response.
Oh,
I was
Yeah.
mentioning. We were talking about short-term memory, and I feel like visualization is
Well,
part of that. But like, because like there's a certain, if you try to visualize again like the solar system or something with a lot of like individual things that are moving around, like there is a limit. At least seems most people there's a limit to how many you can handle. And another limitation of the brain seems to be, the number of dimensions we visualize things in. I mean, obviously we evolved 3 dimensions, so. But yeah, it's interesting how far can you push it?
Sorry.
I was going to say I have a question that might bring this back around to a conversation on augmenting cognition. This is something I've been curious about. So there's technologies. I don't know if any of y'all have heard of BrainPort. It's been intensely interesting to me since I found out about it. But basically, it's a series of electrodes on your tongue, and if you train with this thing and you look around at things at the same time as you have electrodes on your tongue, then you can train so that you can see through your tongue, basically. So your brain sort of remaps.
Not through as in transparent, but use your tongue to see. Just to be clear.
Yes, use your tongue to see. So the brain can sort of remap your senses. And I've always been curious with this idea of hyperdimensional visualization. If folks think it would be possible to remap some sort of information about the 4th dimension, for instance, to like audio and play it through headphones and create some sort of qualia for hyperdimensional visualization in that way.
That'd be pretty interesting. Do we know, like, what would such an experiment look like?
You could also expand that to olfaction. Potentially some animals have this.
Yeah, so there was a macro
like
question.
Olfactory pathfinding, essentially, like directionality and
Yeah, well, audio is interesting because we have. Like, go ahead, Elon. What were you gonna say?
Oh no, I was just saying there's just sort of a sort of a larger insight in general, or a question, I'd say, a macro question, which is very related to the sort of earlier conversation, Ekkolápto and all of that, which is how arbitrary a function can our brain learn? Is the fact that we live in a 3D world, and is that even right? It's not even really true. We live in it, right? Who knows? But in a certain sense, is there a limitation in our brains structured in such a way that they are sort of hardwired ultimately to have the kind of perceptual capabilities that we have, or is it just by virtue of how we end up operating in this world and that they get built that way? And then the question is, could you have a very radically different function that say it's a function between perceptual state and action and then the next perceptual state, however you want to define your kind of perceptual loop. That seems like a really broad way of characterizing this, and I think the answer is we really don't know as a species until now, because we couldn't modify this stuff. You couldn't spend time in a 4 or 5 dimensional space moving around. There was no such possibility, and so. Which kind of is, why we have the question, right? Because maybe the world is, maybe we perceive in 3D because we have always perceived in 3D, and we've never had the opportunity to perceive in higher dimensions. Or maybe it's because our brains, over the course of evolutionary and developmental history, because we do perceive in 3D already, because somehow like perception action is 3-dimensional in some weird way, whatever that means. Therefore, our brains end up having actually hard-coded features that mean that we can't just learn some other function. So it seems like it's an interesting question. I think you could even, there might be even literature that would be relevant to that sort of macro question that I think Ekkolápto should be worrying and thinking about. Namely, if the goal is modification, sort of cognitive modification, just how plastic is the system is one way to think about it. At a sort of macro level that you start to dig in. But I think this kind of thing, visualization in a higher dimension, it's a great one where you could say, spend a few days in there. Remember the famous, everybody knows the famous inversion experiment.
Like the goggles.
Yeah.
Yes.
And somehow, in some ways, that argues for like, wow, crazy plasticity. On the other hand, it's still 3D, and you end up with the same thing. It's the same representation. It's just you did the literally just spatial inversion of coordinates. So that
I heard that John Conway used to like go around with like these goggles that like output his like eyeballs over here.
Right.
Made them
Right.
wider.
Exactly. That would be the interesting case. We had thought about it in the lab. We talked about it, a 360 camera. But in your 360, you start to eventually see the world in 360 degrees as you move through it.
I mean, that's kind of like
anybody willing to spend about 3 days?
Eyes on the side of the head.
Anybody willing to spend 3-4 days straight? And reversibility is very likely. No, I'm sure it'd be reversible. Really?
Yeah.
We should do
builds
that.
it, I'll do it.
We should do it. You want to spend a few days in a 4-dimensional space and see how that goes?
Yeah.
I'm down.
Huh. That's a pretty cool idea.
Definitely be fun.
How would we measure the effectiveness?
Yeah, so you have to have some.
That's a 4D Minecraft thingy, right?
What?
There's this game that somebody's developing. It's like a 4D version of Minecraft or something along those lines.
Voxels.
Not sure.
Yeah. Well, you could just have literally some sort of objective task. I guess in Minecraft there are, right? You can have an objective task.
Sure.
I don't know much about Minecraft. I'm sorry. Wasn't
And
around.
then there's Magakure, which never comes out.
What's that?
Magakure. Magakure. It's
link, please. Sorry, I missed
something
what did you say,
I was
Trevor?
actually gonna bring up on this idea of visualization and sort of hyperdimensional stuff is, do you remember the other day when I was telling you about like those ghost sensory experiences? Like it's a color that those new, a sound that was new, a feeling that was new that you couldn't describe. Is that somehow related to this way that we would potentially perceive higher dimensional spaces in vision or sound or smell or whatever? Because I feel like there's something there.
Well, we wouldn't know until we tried, but it sounds to me like nobody here has experienced anything like a qualia change. Whereas what you're talking about, and it's correct me if I'm sort of the idea that if you present certain kind of associations between different modalities, you end up sometimes with a new sense, you called it, right? Like it's a new qualia, like something that's not just I have visual and auditory at the same time all the time, right? We're doing it right now, but they're distinct. There's no merging into something that's.
But would experiencing the qualia of a higher dimension be so new and different that we would almost experience it as something an entirely different qualia, right?
That's sort of
because so people will say that they'll have these experiences on like very advanced meditative experiences through the jhana state, stuff like that, even on psychedelic episodes, right? There's all sorts of different experiences people have, and we haven't really like rigorously studied this, unfortunately, right? But I do think that there is something interesting about the way your mind is producing states that are foreign to itself in a sense, right? And I do feel like, in a sense that's kind of what you're doing if you're trying to imagine and experience higher dimension. And I guess the bigger question too is that why is this useful, right? Why is this actually useful to visualize higher dimensional states, except for maybe mathematicians and physicists, right? How would say, maybe artists as well to a degree, but how would a physician or a physician or an athlete make use of something like this? Because I don't think it's just going to
I'm curious if it would help with memory.
I think there are special neurons for vision, for spatial reasoning.
Sure.
These place neurons, place cells or grid cells. There's grid cells, right? So I think a lot of there's also who is it? There's a woman who argued that a lot of the things we do, like with mathematical reasoning, language, are actually trying to utilize these place cells, grid cells that are more evolutionarily primitive. So
Got a link on that?
I have to dig it up. Like, but even in like even like a lot of the ways we talk about things have a analogy to spatial position. So like we say, working at a higher level of abstraction or something, like there's a lot of these expressions we have which are tied into spatial relationships. Or you're saying I'm feeling down, like I'm feeling bummed out, but it's like lower level, Anyway, but it seems like a lot if we can utilize these the neurons that are dedicated to spatial reasoning for other things that are not so for like mathematics and other things, or even that could be useful. Kind of a general point, but
I'm curious for general memory, because spatial memory tricks.
Yeah, that's
like put
a good
this
point.
part.
Yeah, exactly.
I think
I'm just
if we can, I mean, even if you can't justify it, like we're not applying for grant yet, right? It's really just, for me, I think it should be of interest just to see whether this kind of modification is possible, and then that opens the opportunity. Okay, well, if you can remap your spatial reasoning and even navigation ultimately you're doing a different function there, and if you can do that, and maybe fairly easily, then that opens up the possibility that other kinds of remappings may be possible. So I think it certainly has value in that sense.
Is the idea, just so I understand, is the idea that a psychedelic experience, if utilized in like a meditative state as opposed to on psychedelics, can be utilized for memory purposes? Like this, because you mentioned like when you do psychedelics and you see differently, right? Is it tapping into that seeing differently in order to remember more?
Well, in a sense, but actually what I would kind of elaborate on more, and there's not enough of like proper rigorous research for us to speak super definitively about this, right? But the setting off your trip and experience makes a big difference in your mindset and all of that, right? And it's interesting to see like what would certain cognitive tasks, what would the output be of certain cognitive tasks if you're under a psychedelic? And remember, you can't just look at it in the short term, because maybe your brain adapts and utilizes it in some way so that in the future you end up coming out with some different ability, right? And I will mention something. I think I made the joke a while back that I never really understood trap music until I had an experience with lean.
So
I never
psychedelics.
really.
So the way I see it, not to cut off, is just that psychedelics as a way of enhancing cognition are of great interest to Addy and Ekkolápto, but I see it more around that being more around enhancing creativity and being able to draw connections between things that normally you wouldn't draw connections between. What we're talking about now, we're talking about utilizing, say, neurons that normally are used for visualization or mathematics, or usually, in a more extreme case, would be utilizing neurons that are normally for olfaction or something like language. Can you, like, this whole idea that's a very unusual. I have not heard of anyone ever discussing anything like that, but that's kind of what we're talking about. Psychedelics might come in here because when you take, a lot of people report synesthesia in psychedelics, right? So
sure.
In the psychedelic state, sounds often have a visual component. what I've observed, but I guess other people have observed other things. So that
Do you know, are there
psychedelics might
like
be a way
neuro?
of training or basically allowing you to connect sensory
Well,
modalities, in new ways. I don't know.
yeah, but do you think that
Do you
that
know
would
if there are
help?
like any imaging studies indicating that psychedelics do have this effect on brain regions? I don't. Do you know any offhand?
Well, there's fMRI studies on how the regions are there's more crosstalk between regions and stuff like that. I don't know about synesthesia in particular, but
Because I'm wondering if
Wait, I have an idea. If
Yep,
you were
go,
able
Michael.
if you were able to induce a synesthesia-like effect where abstract concepts and ideas had a visual qualia associated with them, and the person involved was also able to think visually, then that might allow them to like expand like their like consciousness buffer when they're thinking about like a lot of different concepts all together, and be able to come up with like a lot more ideas, like as was mentioned previously.
Michael, I have a lot to say about this, and I know we've spoken about this, but I'm going to add to that, and I'll say, I've spoken to other people that also do this, but I can directly speak from my experience. But what I'll do, like let's say the example I always give is, let's say I'm trying to make a drawing or a painting on a canvas or a paper, right? And I have the restrictions of that medium. It's a white paper, and I've got a pencil or whatever, right? It could be as simple as I'm thinking of, a face or object or whatever in color in my mind, and I have to translate that over to the paper, right? And so, it'll go to black and white and these shades or whatever, right? But what's really interesting is, how do you think creatively about something visual through, say, olfaction or sound? So something that I've actually done for a long time is that, if I'm trying to draw something, or if I'm thinking of an idea, like if I'm thinking of an idea now, like if I want to go and do something later on in my day, I'll switch it into something else that's not that. So if I'm thinking of something visually, I'll think of it in terms of a sound or a smell or whatever. And then I usually, when I translate it back into the visual information, it's a very, very different, like abstracted creative idea. And actually, I can say this in like the drawing process or whatever, right? Is you could think of an idea in terms of sounds, feelings, emotions, whatever thing you want to talk about. And then you have to be able to translate that over into the medium that you're trying to communicate it and express it in, which in this case would be a paper, or in this case, the English language, right? And I found that there's a lot of people, even some that you may not even consider to be, not neurotypical, that have very odd ways of thinking about information like that. And I think because there's such a distance, it helps you kind of create these more abstract ideas. Is that kind of what you were getting at, Michael?
Maybe. I'm not entirely sure. I mean, like, it allows you to think with like different modalities.
As in, you're saying you could represent vision in terms of sound, or smell in terms of color, or stuff like that.
Well, it's more like you taking different concepts, like abstract ideas even, and representing them like visually, such that you are able to think with them like in the visual sense.
Yes.
Because I feel that I think like vision has like the most information density, but I could be horribly wrong. I mean, at least for me, I think it has the highest information density than the other forms of qualia, and I can think visually. So I think that if I were able to like convert abstract ideas into like visual qualia, then I could use those to think in a more efficient manner.
Curious what you guys have to say about this.
Yeah, I think you have to be a little careful, because the amount that we're actually aware of is in vision is generally lower than you think. Like there's that famous example of the guy in the gorilla suit that people missed. I don't know if you're familiar with that, and the other thing is like, this is kind of a general point I made it to Addie a while ago, is I think there's a lot of these great ideas, but we need to come up with rigorous ways of testing them.
Yeah, I want to.
Yeah. So, because it's easy to deceive yourself, especially when you're talking about psychedelics, because psychedelics often give you this sense of profound insight or meaning or revelation.
Yeah, the false insights.
Yeah, and then,
Well, they may not,
then
you don't know
like,
if they're false, but they're not. They're hard to transport back to your
like,
non-psychedelic state. So.
You realize it's just like it's actually something.
Well, it could be there's insight in that state. I mean, you don't necessarily have to, but
like for instance, just for any of these things, like like for any of these practices we're talking about, we need to have a way of rigorously testing if there's utility for something, right? So,
or at least, or if it's efficacy, right, at the very least. So I was going to say, about it's actually problematic in some ways. Like, okay, psychedelics, you end up people get like synesthesia. Well, that means it's probably a state that is really hard actually to just self-induce. And the fact is, people see associations between things for their whole lives, and they don't develop synesthesia. It's a weird. I'm sorry, I shouldn't use that term, but it's a minority, a very small minority of people who are synesthetic, which means in some ways the lanes and the grooves are kind of very firmly set, probably through developmental experience, also some genetic component, whatever the case may be, which to me is like, okay, that's actually headwind in terms of thinking about modifiability. The fact that you can get into an altered state, well, that means it's an altered state, right? And it's not necessarily that it's reachable without, say, sort of chemical facilitation or something like that. So that's, I think,
this feels testable.
I was also going to say I don't know how easy it would be, because you can't usually remember like when you're tripping on psychedelics. And so even just being able to say I can meditate my way into tripping, but like, do you even remember those parts of tripping?
You'd have to have some way.
How much we can test that, and then decide if you can induce that without a psychedelic. I don't know how to draw that.
What if we just use tasks and just use a task that you're uniquely better at in a certain state? Like, why don't I'm sure no IRB will ever approve this, but I'm sure we can find some shrooms and do some shrooms and see if you can solve a 4D maze better.
If you want to know, if somebody would have done it in Johns Hopkins, they've been doing psilocybin research consistently since it was banned. I mean, it's been a long history there. They may have looked at exactly that kind of question. But why is that of interest? Because we don't want it to, right? I think the purpose here is to think about things that people can implement probably without.
Yeah.
I mean, maybe, look, there could be a side sort of quest in some ways of what insights or maybe are possible in behavioral practice, whatever, in those states. But it seems like the goal here is really something that's more of a fixed kind of nature that you can use as a tool in your life, for maybe as a permanent modification or something like that.
Shrooms are not that hard to get a hold of.
No, but it's more like if you're saying, oh, can I meditate into like being synesthetic? Can I meditate my way into being synesthetic? Because the meditation is so much like shrooms. My issue would be, do you even really know what shrooms are like if you're not actively on them? Because memory, there's like, people remember specific parts, but like memory is kind of shot. So
sure,
there is no real way to be like, okay, this is equivalent to this experience, even though it isn't this experience that I don't really remember.
But is there a functional correlate?
Therefore, that's going to be useful for this other thing.
So I can think of a lot of different tests. So like one would be, so like a very fine-grained test would be, so like chess ability, like it's like, or some kind of game like that that involves a lot of cognitive processing, or but another kind of more general thing would be scientific productivity. So like we have ways of measuring, like we have these very crude ways of measuring product. We don't have good ways of doing it, but very, very crude ways, like number of citations, the H index of journals that you publish in. So like, an interesting question would be, does a scientist who takes a psychedelic every 3 months end up being more productive over a period of 10 years than a scientist that a similarly capable scientist that isn't taking the psychedelic? Like, we have a lot of interesting ideas that we just need to have frameworks for testing them rigorously. That's all I'm saying.
Yeah. Yeah.
But I agree 100% with what Daniel said.
You know,
like,
You're really
I
breaking
agree with
down.
Daniel, what Daniel's saying, but do you see there's a bright line between two different categories of sort of neuroprosthetics?
I sort of do because one is sort of offloading cognition, like, for instance, having the AI do a lot of the heavy lifting. Now, there's an interesting question. Can you sort of, how tightly coupled can the human and the AI be? Like, can the AI actually be thought of as an extension of your brain? But I think that, I think one of it's more offloading into AI.
The conversation by the way is offloading, right? And like anytime
but whereas the other is working with the wetware of the brain and that, pushing the brain itself in different directions. So I do see a pretty distinction.
So external tools versus internal tools. Could we just something like that?
Yeah. There's the whole extended mind hypothesis that like maybe like the notebook is an extension of your brain, but basically I do see a pretty clear distinction. So it might be good to like focus in on one.
Personally, I'm only really interested in internal stuff.
And a lot of these discussions with Addie, they do tend to bounce around a lot, which is great because they, we get interesting connections, but at the same time, you also want to focus.
Does a psychedelic or a Neuralink or something like that count as an external or internal tool?
If the goal is for it to modify your cognitive abilities of the brain as an organ, it's internal. And I think if the goal is for it to allow you to interface with something in the external world better, it would be external. And that's sort of where I would draw the bright line.
What if it's like to do so temporarily, or to see what lasting effects it has, or just as a test tool? Where's that?
These are good questions. I don't have the immediate answer. We may not be able to slice it so thin that we.
Yeah.
You can retract your vote and say, "Wait, I didn't mean that. I guess counts as internal or something like that."
I would count Neuralink as external. I think not because it's like interfacing with internal or external world, but if we're talking about it in terms of like meditation versus, drugs or Neuralink versus whatever, I think that internal would be a process that we can naturally tap into without using necessarily.
Oh, wait, does that have to be natural? Hold on. Now you had a new criterion.
Whoa, that's
not natural, but like without other tools, right? So like without having to say, okay, I need to get this, or if I could just sit in my room with nothing, and I can do
psychedelics also
internal.
You consider
psychedelics? I need something. I need something external to do that. Right?
Well, there's also experimentation, right? I know we're sort of derailing again, but experimentation into sleep and dream. There's something called like sleep or dream yoga that people will talk about, but people will specifically try to get into certain types of dream states, hypnagogic states or whatever, to have these sort of interesting sensory experiences, right? And I do know there were some notable people that would say they get into the state and that would help them come up with ideas. And I think like these were like famous inventors or whoever. And I do wonder like what other states are like that there that we're just not thinking of taking advantage of. Right. So again, that's going back to the main goal of like, how do we actually enhance their cognition to get better at these tasks?
I mean, at least for me, my question there is, what are those states? Why do they exist? And what do they do? Not so much like how are they, as in being in those states of cognitive enhancement, but what elements of those are different in cognition, and then how can those be isolated?
So
I don't know if anyone else is with me on that.
This might be another bright line that we can divide the conversation along, which is sort of pure scientific interest on how the brain works versus more applied interest on how we might make the brain work better.
I think so. There's the applied. There's a couple of different actual boundaries that we can draw. There's applied versus. I think we were all settled on applied. It seems to be like the theme. And then there's the internal versus external, which is a sub-theme. I thought we'd already settled the applied one. Although I'm not.
In terms of apply,
I'm
right? So
personally not that
I can
it's
mention
not
the
my
thing
thing,
about
so.
synesthesia,
What? Your
right?
person?
In terms
What?
of the applied
It's not
thing,
my
right?
thing. It's not my thing.
In
Sorry.
Yeah,
the case of the applied thing, right? So, you know, if you learn, like, say, the olfactory language and you associate that smell with another smell, or that smell with a sound or a visual or an idea or whatever, you start to build up this very interesting way of perceiving smells. And if you try this for yourself, like, relatively quickly, you'll almost feel like other things now have a sense of smell, like a smell representation. It's not saying, oh, like this book literally smells like this, but it's like an entirely different smell that's associated with it that you're using it to process things in your head, right? And then you can think about it and combine it in different ways and come up with some really interesting perspectives. So I do think that synesthesia is learnable. I do equate synesthesia with language, and I think there's a lot to be done there because, you know, let's just say, you know, you're a cook, you're in the culinary arts or whatever. Is it helpful for you to cook only in smells or only in taste and smell or something else? And I think if you want to get more abstract and have more room of combining and experimenting with things, you can disengage from, say, the olfaction and the taste and go into something visual or auditory, and then translate that back into, you know, the taste or the smell to get back your original form of things. And, you know, this is something people can kind of try. And yeah, this is a practical sort of biohacky way of doing it, but I also think it has some very interesting implications for the way that we test and understand, you know, perception and language in the brain, which maybe is something Alon could talk about.
Yeah,
I'm too busy thinking about what you just said.
I think we've always had an applied lens, but and I think yeah, because I think you can it's not in conflict with deeper understanding of neuroscience either. So you can, like, a lot of these, and going back to, like, John Vervaeke, a lot of these practices that we thought, you know, were just sort of abstract explorations of consciousness may actually have utility for us. So anyway, and again, there needs to be, anyway.
There's one other sort of intermediate level of applied, which is where it's not applied in the sense of we're applying this for a end goal, but rather it's applied in the sense that we're using this as a technique which can allow us to have a concrete objective test.
Yeah, exactly. And that's where I'm like, okay, that's why I'm interested in it.
That's what I'm at.
Exactly. I mean, although I'm very sympathetic with the idea. I've grown more sympathetic. I told Addie this a few times, which is that I had never thought, oh wait, if you have this insight, maybe it'll be useful. Like, what do you mean useful? I'm just trying to understand things. So it was a very academic kind of, in some ways, you know, very limited way of thinking about stuff. But the reason I'm still, even if I leave that aside, the utility, I think there are very interesting questions about utility as a test of a thesis, of a theory. So if there could potentially be some insight you can have from a theoretical construct that would then end up being behaviorally efficacious, well, then that kind of validates the theory on some level. So if thinking about cognition, thinking about, let's say, memory in my case, is thinking about it in terms of next token generation, or it's predictive, it's a sort of a generative model, not really predictive, but generative model, then you can actually use that fact. Let's say what you're thinking about it computationally that way, makes certain predictions about enhancement of, let's say, what are you trying to do? Not increase your digit span, because that's dumb. You don't have to remember phone numbers anymore, right? So you don't need that. What might you want to enhance in terms of short-term memory is your ability to maintain sort of a longer-term consistency as you're, more, so you can have more complex ideas that take more time to develop, or something like that. Well, thinking about it sort of visual activation, maybe there are actual predictions that come out of a particular theoretical framework that then you can test, but also then have utility, right? So then everybody's happy, because then Ekkolápto is like, yeah, we're actually enhancing cognition, and I'm happy because I'm like, oh yeah, it turns out this theory is correct, right? And so these are certainly not at all mutually exclusive. It is
Not
definitely
in the slightest.
right. So I think we can, I think everybody can sort of certainly say that these two are, assuming that you're in the insight camp, and maybe that's just me, but
I am.
okay, then you can still certainly see utility in these conversations, because again, I don't know who I would talk to. Let's say I'm like, man, how do I test this? So you could do experimental, we could do just sort of standard experimental work, but what about people who are willing to like take on a new practice, right? And try to use it in their lives? That's actually much harder to, you're not going to find experimental subjects necessarily who are going to do that. They'll do it for a half hour, an hour in your lab, and boom, but how about, Dugan was willing to put on sounds like a VR headset for 3 days, right? That's commitment. So you kind of need people who are like willing to be psychonauts, I guess, to use a term that's used in other contexts. But this is kind of, this group, it seems to be a potentially a really rich, fertile place to find such people. And it's good to all talk to one another. The insight.
Yeah, Elon, that's I'm gonna think about that. I think that is a big constraint, actually. Is getting people, because I'm gonna have to think about that.
Yeah, and and I actually, I'm Daniel and I are involved in this this completely aside, not particularly related, but we use ML and stuff to really scrape and find conversations in social media around new psychoactive substances. But these are psychonauts, and if you read, they see themselves very often as pioneering, kind of exploring new frontiers of mind, but it happens to be specific, and the term specifically means using some sort of chemical agent. But what about other kinds of psychonauts, right? And of course, Buddhist monks are certainly psychonauts. Whatever, spending hours or days or months in meditating and going into clearly, different mental states, cognitive states, there are different kind of psychonauts. And so this is sort of like that, right? This is kind of people who are willing to go and boldly go where no mind has gone before.
I've been listening, and I've drawn up a little bit of a Punnett square between what I've been hearing folks talk about as sort of the various topic areas. So if folks wouldn't mind me screen sharing real quickly.
Yeah, care to share?
Yeah, absolutely. As I see it, kind of a couple of different axes here. We've got internal methods and external methods, and we've got insight as sort of knowledge for knowledge's sake and application. And we've got lots of people here who are in several of these categories, but I wanted to draw this out. These are not perfectly phrased questions, but I think sort of if we look at internal methods and insight, we can ask, what is meditation, psychedelics, etc., reveal about the mind? If we look at
sorry, I have a question, but can be. I think my question from before was just, are we considering psychedelics internal or external? Because previously I would have considered it to be external because it's an external tool that's being applied and added and changing some sort of chemistry or whatever. And then, so I think that was just what my question was are we considering external? Okay. That's what I was thinking.
I was thinking internal as in, are you modifying the brain as an organ, or are you extending the brain in some way with technology? So maybe modification.
We need a cube.
I think it's internal because you're pushing the brain into a specific state, and a lot of people say that the psychedelic states can be at least partially gotten without taking a substance. But
we kind of need a cube. Like,
have you looked at that? Yeah, but I guess so. So the other half of my question was: is there any way to equate? Because if we're going to consider them under the same category, then are we then equating what we can do with meditation to what we can do with psychedelics? And then if we're making that assumption, then how can that assumption be measured or defined? Because I don't know that there's a way to say that for sure.
I don't know that I'm saying we're making that assumption. And I just modified this real quick here. I think to talk about more exactly, maybe a more useful way to talk about it is modification methods versus extension methods.
Okay.
So are you modifying the way the organ of the brain functions, which you can do through meditation or psychedelics or other things? Or are you extending the brain in some way, sort of in the formal Chalmers-Clark extended mind? type of idea.
Thank you. That makes a lot more.
Yeah.
And so
Once we make that distinction, though, I don't even know that we've barely touched actually on extension, right? I don't know if Ekkolápto is that even a major part of?
I didn't know. That's why I was thinking that we were doing either or.
Yeah.
And that one of them was psychedelic and the other was. So now, yeah, I didn't know that.
And if this is a way of cutting off topics from conversation and focusing in, I'm okay with that. If we're saying, all right, we're not interested in a chunk of this Punnett square, I'm completely okay with that.
So, but we could do a different square also that would be external agent versus internal agent, right? So there's different things.
The only, yeah.
That makes sense.
I think Addie's ideas and a lot of the most compelling things that I've seen from Ekkolápto are in the under modification. But
yeah, that's what I think we're at.
What modification? Sorry, say it again.
But modification.
I can agree with that.
Yeah, but you know, we're also we've got people interested in AI, and we've got people interested in other, you know, some of the.
Look, I mean, I think about AI all day, but I'm happy to think about it in this context
As a tool.
Yeah, and again, or to Misha's kind of
scientific research ability or whatever.
It's sort of how martial artists would say, you know, the bow staff or whatever was an extension of your body.
I think this is super helpful. Yeah, I think this is super helpful. I think we should put this on the Ekkolápto website.
I see the internal versus external division as a further division of sort of the modification side of this.
Yes. It's like a branch off of the modification into the different forms of, because I just don't know. I feel like during this conversation, we said different forms of modification, like psychedelics or meditation or what monks do. And those are, I think that those are probably sort of different in the way that they're done and in what you get from them.
Well, the thing that I wanted to get into more, right, and we touched on this on the last one. So bringing this idea of a mind, right, is the way that we process the information that's kind of coming in, the way it's interpreted, right? And I gave, an example the other week about, say, people with allergies or something. Well, remember this? Why is it that, you can have something that you're allergic to, and if you cut it up into very small doses and you sort of distribute that throughout time, all of a sudden now it doesn't cause the same response anymore, right? And this is the same thing with the way we get accustomed to information, right? If you look at something for too long, your attention doesn't really pick up on it anymore, right? And I see some very similar properties between how, say, digestion and the immune system work, and then how we attribute, cognition to in the brain. And I actually think we can learn more about the brain, too, as the cognitive system from looking at these other more diverse forms of intelligence. All right, so that's why, to my point, that's why I'm not saying specifically a brain. I'm saying a mind or a cognitive system, because this is just beyond.
Yeah, I think the lower two squares is where Ekkolápto is. Not just the lower left, but both the lower two.
So application.
Both the lower two?
So we're talking about
because
both
extension
modification and extension.
We get into I just have noticed a lot of the discussions at like the hackathon and stuff was also about improving health and well-being and that's
oh my God, hi Bailey.
That goes under. Well, it's more the lower left, but yeah. I'm interested in the lower right a lot, like what you just said there. What technology could improve? So I'm very interested in that. But what technology could accelerate scientific progress? Coordination. So a lot of things can go under the lower right. So better. So. I would maybe put a list of things there, like how do we interface with, how can we offload things to AI? How can we work with AI in a synergistic way? How can we better coordinate multiple groups of people to solve scientific problems? How can we have better social systems for funding for science, better institutions for science, and also even like yeah, those would be the main ones.
That's not even limited to what we would traditionally call technology. That's very broad, right? You're saying, what are the practices and technologies potentially
I mean,
facilitate?
in a sense, learning physics for someone that has never done it before could also, accelerate progress to a degree. I'm just very interested in the way that we're actually defining all of these terms, because on the surface, if you say, oh, what practices and tools, that someone could implement that would change their cognitive system, whatever, that could be, a lot of people will just think of, basic meditation or exercise or whatever. No, I think there's, I like to say I like to think very widely about very simple things. So that statement is very simple, but my mind kind of goes elsewhere with it, right? And then also, what technology would someone use? Like, is that just a better computer, or is there something else about the way that we're interacting with the world that could give us better insight into things? And so I guess the way to also sum this up is that Ekkolápto likes to think about simple things very, very wildly and unconventionally. If that makes sense. So why is it that, for in the case of humans, right, that we've basically relied on visual and audio information, right? We don't use smell and taste in the way that say other animals do, right, or feeling, or touch, but we will mostly use audio and vision. And I think part of that is because you can write something down with the current physiology that we have, and you can also make a noise. And it also happens to be that a lot of people think in terms of words and audio and visuals. And I think those things go hand in hand. I think if we were a more, olfaction or taste-based, civilization, is that maybe our internal monologues, our inner voices, our internal tulpas, whatever, would take the form of, say, olfaction or taste more. Does that make sense?
Yes.
Yeah, I agree with that a lot. I mean, I think that our cognition is mostly syntax of sensory perception.
So my project is looking at speeding up the simulation of artificial life with some foundation models. So that means you would just take some language prompt and then generate these life forms, and then you take snapshots, images of these forms to compare to the language prompt to see how similar they are. And then I plan to use some measurements like complexity measures, KL divergence, and then neutral information, synergistic information, and so on, to try to quantify the complexity. And just curious if people have other ways to quantify this complexity, intelligence, and related thoughts.
I know assembly theory is very hot here in terms of if you can talk about your system in terms of different components coming together, then you can quantify the complexity in that way.
Sounds interesting. Can you elaborate?
Yeah.
What theory?
So assembly theory basically says you can have an assembly index of an object, which is, so humans have a very, very high assembly index because we have sort of a handful of amino acids that come together to create cellular components that come together to create cells, that come together to create organs, that come together to create humans. And so they're sort of, from a simple set of raw components, there's a lot of different ways that they get put together and get arranged to make something like a human. And in general, if you talk about things in that way of like how many different ways are things getting put together, it tracks pretty well with the complexity of whatever you're talking about. So like with a rock, you just sort of have minerals stacked on top of each other and things aren't put together in very interesting ways. And there's not sort of this emergent property where these things together make this and then that together makes this. It's just minerals in a big clump.
I see.
And so if you can talk about things in that way.
I kind of have to drop at this point.
Me too. Thanks everybody. This is great.
Yeah.
Really great to meet everyone who I haven't met before. Thank you, and I hope to see you again.